welcome to this tutorial on a power series. Today, we'll learn how to determine the radius, center, and the interval of convergence of a power series using the ratio test. We broke down the process step by step from calculating the limit of the ratio to carefully checking the endpoints of the interval. Remember, the ratio test gives us the radius of convergence, and the center is simply the value around which the series is expanded.
The interval of convergence is the range of x values where the series converge and always need to test the endpoint.
So let me answer the question why power series convergence is important. Is it because understanding convergence helps us determine when a power series represents a function and where it is valid? So, let's dive in.
A power series is an infinite series of the form of summation of c sub n, the quantity of x minus c raised to n, wherein c, or the center, it is the value around which the series is expanded. The coefficients, or the cn, it is the constants that determine the weight of each term. And for our x, or the variable, the input value for which the series is evaluated. And for our n, or the exponent, the power to which x minus c is raised. Now we're gonna talk about power series, and let me give you an example of power series. This power series is centered at 0, so c is equal to 0 for this one. And here's another power series, but this power series is not centered at 0. In this case, the center is c. The first thing we would able to do is determine where it's centered at. So let me give you some examples. For each of this example, determine where each power series is centered at. Feel free to pause the video and try it. Now let's consider the first one at the upper left. Where is the power series centered at? So just by looking at it, we can see that it's centered at c is equal to -2. What about the second one? Another way you could find the answer by setting the inside by x minus 3 is equal to 0 and get the value of x. So it's centered as c is equal to 3. How about the third one? We will setting the inside as x plus 4 is equal to 0 and find the value of x. And x is equal to -4. So it's centered at -4. And for the last one, also we will setting the inside as 3x minus 2 is equal to 0 and find the value of x. Our x is 2/3. So it's centered at 2/3. Radius of convergence. The distance from the center of a power series to the boundary where the series transition from converging to diverging. And the next one, interval of convergence, the set of all x values for which the power series converge, typically written as an interval c minus r, c plus r, where endpoint convergence must be checked separately. Let's consider this number line and place c at the center. Since r is the radius of convergence, when we subtract r from c, we get c minus r and becomes the endpoints at the left side. When we add r to c, we get c plus r and becomes the endpoint at the right side. And this is the radius of convergence, or the distance of the center of a power series to the endpoints. If the x lies to the right side of c plus r, the series will diverge. Similarly, if x lies to the left side of c minus r, the series will also diverge. However, if the x value lies between the two endpoints, the series will converge. Or in short, if the absolute value of x minus c is less than r, the series will converge. And if the absolute value of x minus c is greater than r, the series will diverge.
We have three conditions for finding the radius of convergent and interval of convergent in a power series. We only discussed the case 1 and 2. Case number 1, limit as n goes to infinity of absolute value of a sub n plus 1 over a sub n is equal to 0. And case number 2, limit as n goes to infinity of absolute value of a sub n plus 1 over a sub n is equal to infinity. In case number 1, the ratio always give a 0 for any x, meaning the series convergence for all real numbers, which implies that for all values of x, the ratio test give a value less than 1, meaning the power series converges everywhere. While in case number 2, which implies that any x is not equal to a, the ratio test give a value greater than 1, meaning the power series diverges everywhere except x is equal to a. The radius of convergence is 0.
We have the example of case 3 in power series, but before that, we need to know the formula. So, power series wherein limit n approaches to infinity of absolute value of a sub n plus 1 all over a sub n is equal to n. So here are the example. Summation of negative 1 raised to n plus 1 n square times x plus 2 raised to n all over 3 raised to n as n approaches to infinity. So apply the ratio test to the given problem. We have negative 1 raised to n plus 1 plus 1, then n plus 1 square times x plus 2 raised to n plus 1. all over 3n plus 1. Then multiply the reciprocal of a sub n. So we have 3 raised to n all over negative 1 raised to n plus 1 n square times x plus 2 raised to n. By simplifying the given problem, we can eliminate the same terms from the problem. So, negative 1 raised to n plus 1, then negative 1 raised to 1, n plus 1 square, then x plus 2 raised to n, and x plus 2 raised to 1, all over 3 raised to n times 3 raised to 1, then the reciprocal 3 raised to n all over negative 1 raised to n plus 1 n square times x plus 2 raised to n. So we need to cancel the same terms. So we only have the remaining negative 1 m plus 1 square, then x plus 2 all over three n square. So at this moment, let us expand the n plus 1 square. So we have n square plus 2n plus 1 instead. So since in power series, we should take the absolute value of limit as n approaches to infinity of absolute value of a sub n plus 1 all over a sub n, we can already eliminate the negative 1 to the problem. So we have now n square plus 2n plus 1 all over 3n squared times x plus 2. So let us apply the L'Hopital's rule. So limit as 2n plus 2 all over 6n times x plus 2 as n approaches to infinity. So the answer is 2n all over 6n times x plus 2. So it is also a indeterminate form. So we need to apply the L'Hopital's rules. So 2 over 6 times x plus, then 2 over 6 times x plus 2 is equal to, or 1 over 3 times x plus 2. So applying the case 3, wherein 1 over r, absolute value of x minus c less than 1, 2. So copy lang natin yung 1 over 3, absolute value of x plus 2 less than 1. So we have here again the x minus c, absolute value of x minus c less than 1. So copy lang natin yung x plus 2 less than 3, which is yung ating
negative
reduce.
3 minus
so
2
let us take
less than
the
x
positive and negative side of
3
the
minus
given radius
2
and simplify
or
to get less than 3 minus 2 to get the interval. So negative 3 minus 2 is equal to negative 5 less than x less than 3 minus 2 is equal to 1. So, we have the intervals negative 5 and positive 1. So, this time, let us check if the given intervals are included or not to the given x values by substituting the intervals to the given problem. So, we have summation of negative 1 and plus 1 raised to n plus 1 n squared times x plus 2 raised to n all over 3 raised to n. So, isa-substitute lang natin yung negative 5 sa x. So, we have negative 5 plus 2 raised to n all over 3 raised to n. Then, negative 1 raised to n plus 1 n squared. Then, negative 5 plus 2 is equal to negative 3 raised to n all over 3 raised to n. So, we notice that negative 3 raised to n all over 3 raised to n have the same exponent, and we can combine those terms. So, we have negative 1 raised to n plus 1 n squared times negative 3 all over 3 raised to n. So, we notice that negative 3 raised to n all over 3 raised to n have the same exponent, and we can combine those terms. So, we have negative 1 n raised n plus 1 n squared. Then, negative 3 divide 3 is equal to negative 1 raised to n. And negative 1 raised to n have the same basis, so we can multiply those two and their exponents. So, negative 1 n plus 1 plus n squared. So, simplifying the given, we have by simplifying the given, we have negative 1 raised to 2n plus 1 n squared. So, we notice that negative 1 raised to 2n plus 1 is equal to a negative 1. We can change the negative 1 raised to 2n plus 1 by negative 1 in the problem. So, we only have negative 1 n squared or negative n squared. So, let us take the limit. So, negative n squared, we have negative infinity square. So, it is a negative infinity. So, we notice that the answer is infinity. So, this is a divergent, and negative 5 is not included to the intervals. For positive 1, same cases. So negative 1 raised to n plus 1 n square times 1 plus 2 raised to n all over 3 raised to n. So negative 1 raised to n plus 1 n square. So 1 plus 2 is 3. So 3 raised to n all over 3 raised to n. So we notice that we can also combine 3 raised to n all over 3 raised to n. So negative 1 raised to n plus 1 n square. Then 3 divide 3 raised to n. So negative 1 raised to n plus 1 n square. So 3 divide 3 is 1 raised to n. So we notice that negative 1 raised to n plus 1 is an alternator. But the conditions are not met in the given problem. So we can directly substitute the limit as n approaches to infinity to n square. So we have limit as n approaches to n square. So substitute the infinity. So infinity square is equal to infinity. Notice that this is still infinity and the problem is diverge to the given x value. So the 1 is not included. So we have the interval negative 5 and 1 for the our center and radius. So for the center, we have our center x plus 2 is equal to 0. So x is equal to negative 2. So our center is negative 2 and our radius is 3.
In all, power series is an infinite series form using this formula. And the radius of convergence, r, is the distance from the center of a power series to the boundary where the series transitions from converging to diverging. While the interval of convergence, I, is the set of all x values for which the power series converge, typically written as an interval c minus r and c plus r where endpoint convergence must be checked separately. And here are the conditions for convergence using ratio test. First, if the limitation of n to infinity of absolute a sub n plus 1 over a sub n is equal to 0, then the radius of convergence r is equal to infinity.
Second, if the limitation of n to infinite absolute of a sub n plus 1 over a sub n is equal to infinite, then the radius of convergence r is equal to 0. And the last, if the limitation of n to infinite of absolute a sub n plus 1 over a sub n is equal to n, affinitive non-zero value in terms of x, then the radius of convergence r is found using x minus c is less than r and the interval of convergence I, c minus r and c plus r with the endpoint of convergence checked separately.
Now, it's your turn to put your newfound skills to the test. I strongly encourage you to practice with a variety of power series. The more you practice, the more comfortable you'll become with identifying the convergence behavior. I have here some examples for all of you to practice. And if you want more, you can work some example from your textbooks or online resources. You'll be surprised how quickly you'll master this technique. Here are the practice problem. Pause the video and try this.
Go ahead and try this. If you found this helpful, please like and subscribe for more tutorials, and don't forget to leave a comment below for any questions or suggestions for more future videos. Happy learning!